In example 4, we still want to find the partial derivatives with respect to each variable, but now we need to apply the chain rule in example 3, or in example 4, like we did in example 2. This will become 3 times negative 2x plus 5 e to the y squared times negative 2x plus 5 e to the y, or times the derivative of that expression with respect to x. So we'll get 3 times negative 2x plus 5 e to the y squared times negative 2 plus 0, just to include it as a placeholder again. Or we end up with negative 6 times negative 2x plus 5 e to the y, that quantity squared. When we find r sub y, we start off the same way. But now when we take the derivative of that interior expression, we'll differentiate with respect to y. Which will give us 0 plus 5 e to the y. Meaning our final result will be 15 e to the y times negative 2x plus 5 e to the y, that quantity squared. In example 5, we'll find delta over delta x of this function. And here we have an application of the product rule, since we have a function negative e to the xy times the natural log of xy. That means we'll take the derivative of this first function with respect to x times the second function plus the first function times the second function differentiated with respect to y. This will give us negative e to the xy times the derivative of that interior function differentiated with respect to x. Oh, you know what? Let me go back. This is still just being differentiated with respect to x. My apologies. So plus negative e to the xy times the derivative of the natural log of xy differentiated with respect to x. So this will become 1 over xy times the derivative of xy. So we'll get negative e to the xy times the derivative of x times y with respect to x will be y. And in the second term, negative e to the xy times 1 over xy times the derivative of xy, again with respect to x, will be y. But now y over y will cancel, and this will reduce to negative y e to the xy times the natural log of xy minus e to the xy over x.